So your assignment was now to figure out what his distance displacement is as this person travels from this side, and now he's moved on to this point. Okay? Now, distance, how far does he travel? Well, he travels 10. Let's erase that. That was part of another. So his total distance is going to be 20. Okay? That seems pretty simple. How about his displacement? Got a little bit of a problem here. He's going to travel 10 meters in the x direction, and he's going to travel 10 meters in the y direction. In algebra, we realize that we can't add apples to oranges, which means we can't add x's to y. Wonderful thing about coordinate systems is that they're at right angles to each other, which means that they're independent. There's a word for that. It's called orthogonality. So when we're talking about a coordinate system, x's are independent of y's, which means that we simply can't add those together. Okay? So he travels, step 1, he travels 10 meters in the x direction, and step 2, he travels 10 meters in the y direction. See how my y has the little hat? Make sure that you don't forget to do that, otherwise it's a variable y, which would be really interesting because at that point it's my. So the way we're going to express this is we're just going to leave it as is. We're going to say that that is 10 meters x hat plus 10 meters y hat. Okay? There's nothing wrong with that answer. That's actually the way I prefer to have that answer form. The reason why I like it in component form is that if I were to add more vectors to this, that the math turns out to be simpler. There is another way, and I'm going to show that. I'm going to record another video, and that is to use trigonometry. If you're not familiar with trigonometry, then please don't watch the video. If you're in an AP class or an IB, and you're not familiar with trigonometry, you're going to still have to watch the video. You're going to have to learn how to do this, because it's important for both curriculums. Okay? But if you're in my traditional classes and you're not familiar with trigonometry, or you're currently taking trigonometry, well, I guess if you're currently, then you should watch it so that you can see some of the applications. But that's the answer for displacement. Now, for position, I've left my origin where it is, blah, blah, blah. You can probably imagine what the answer of this is going to be. Well, it's so far in the x, so far in the y. The answer turns out to look exactly like displacement. Okay? Once again, that question is still floating out there. I want you to try to figure out a way in which these answers can be different. And there is it's kind of an interesting way of looking at things. Okay? Cool? So remember that, looking for that. But here's my answer. So it looks pretty straightforward. The interesting thing is that, well, it looks like I got 20 and it looks like I got 20. I don't have 20 here. I actually have less than 20 for displacement. If you're interested in seeing that, I'm going to show why it's less than 20 when I talk about the trigonometric way of solving this. Cool? Alright, so next slide is going to be on the trigonometric way of solving this, and then I'm going to walk this way 10 meters. Okay? So if you're familiar with trig, or you're in my honors class, or IB or AP, or IB, I need you to watch the next video. If you're not, I want you to skip and move to the next one. Okay?